Good morning. Welcome to our webinar, Which Column Dimension and Particle Size Are Best for Me? Thank you for joining us today. We especially appreciate your attendance right now while many of us are struggling to balance professional and personal needs. We hope you all stay safe and healthy. My name is Tracy Hartledge. I'm a sales representative and project coordinator for Chiral Technologies and will be your moderator for today's session. Presenting today's webinar is Dr. Weston Umstead, Manager of Technology here at Chiral Technologies. Please note that during the webinar, you will have the ability to submit your questions as they arise. Please take a look at the control panel on the right side of your screen and click on the Questions tab to begin. Fielding your questions today will be Bill Watts, a member of our technical team. We have placed a copy of today's presentation along with two other useful documents, an application note, and our product list. They are available in the handout section of the control panel. I now turn the microphone over to Dr. Umstead. Wes, the floor is yours.
All right, thank you very much, Tracy, and thank you again to everybody who is out there listening today. We appreciate you taking the time, given the uncertainty that we're all facing right now, to tune in and learn a little bit about what column dimension and particle size are best for me. This is a question that we often get asked by customers, both new and more advanced, especially when somebody is looking to begin starting a screening setup, for instance, and exactly how they should begin the process, what column dimension, particle size, etc. So that's going to be a focus today. As a brief overview of the topics that we're going to touch upon, I want to start off with just a product overview, what CSPs, chiral stationary phases we offer, what column dimensions and what particle sizes we offer as well. Give you a little overview on that before we actually talk about the individual features of the column and what kinds of effects we can expect in changing column length and changing the column inner diameter, and then moving into particle sizes, what kind of effects we expect to see when we change particle sizes. Specifically, we'll talk about analytical versus preparative scale. That's the major focus of changing particle size typically anyway. And then we'll finish with some conclusions and some email addresses if you have questions related to your specific cases. So in the beginning of chiral chromatography, the choices were pretty straightforward as far as instrumentation was concerned. You were going to be using an HPLC with a set number of mobile phases, normal phase, polar organic mode, and reversed phase primarily. You're going to be using UV detection as your source. There is a slight difference between analytical and preparative scale methods, not necessarily in column dimension and particle size, but more optimizing the method to be able to load more material on the column to run a preparative scale separation, for instance. The most number of choices came in the form of the polysaccharide phases or the chiral stationary phases that were available. And at that point, it was only the coded phases, things like AD and OD, which you are all probably very familiar with. But now the choices have expounded quite dramatically. And for the purposes of our discussion today, as the title of the webinar indicated, we will be focusing in strictly on column dimensions and the particle size offerings that we have and where they all fit into the different applications that you might be looking to use them in. To talk about the chiral selectors first, we'll focus on the polysaccharide phases, which are kind of our bellywick. We have the Chiral Pak line of columns. Chiral Pak encompasses all of our coated amylose as well as our entire line of immobilized columns. And then we also have our chiral cell line, which is the coated cellulose phases. So our first generation coated columns were all of the phases that you're probably very familiar with, things like AD all the way through OZ. And then we have our second generation immobilized columns, which are compatible with the normal phase, polar organic, reversed phase, and SFC conditions that the first generation coated columns were compatible with, except now you can also use them with what we call the forbidden normal phase solvents, things that contain dichloromethane or ethyl acetate or THF. And then we have our specialty selectors, our protein columns, ligand exchange, crown ether, Lindner, and zwitterionic Zwick's phase. And these are all available in a wide variety of different column dimensions, and in some cases, a wide variety of particle sizes as well. So what we offer as far as column dimension options goes, if we look at just column lengths for analytical columns, everywhere from 50 millimeter, 100 millimeter, 150 millimeter, and 250 millimeter length, and for preparative scale, 150 millimeter length, 250, as well as a larger 500 millimeter length column. For column inner diameters, which I will most likely be referring to as ID from here on out, for analytical columns, we're looking at 2.1, 3, and 4.6 millimeter IDs. And for preparative scale, anything from 10, 20, 30, 50, all the way up to a 100 millimeter length or 100 millimeter ID column. And particle sizes, I broke down into analytical versus preparative scale. Analytical only, we're looking primarily at 3 micron, although we can also use our newest line of sub 2 micron columns that have been optimized specifically for UHPLC. It's not that you can't use the sub 2 micron columns on a normal HPLC. However, you generally won't see the added benefits, reduction in extra column band broadening, for instance, that you would see using them on a UHPLC, but they can certainly be used on HPLC as well. For analytical and preparative scale, I have 5 micron in here. 5 micron is very interesting in that it kind of straddles the line between, straddles the line between both analytical and preparative scale. Oftentimes, if a user knows that they're going to be scaling up to preparative, to a preparative separation, they will perform their analytical work on a 5 micron column because there's no unexpected changes in terms of the resolution of the chromatography when you go to preparative scale. And then for preparative only, we have 10 micron to 20 micron. Back in the days of the origins of chirochromatography, 10 micron was the go-to for analytical as well. However, that was because 10 micron was really the only particle size that was available. Now we pretty much relegate it only to preparative scale, and if there are any methods out there on 10 micron, we usually advise that you switch over to 5 micron at a minimum, and of course 3 will get you the extra resolution that you might be looking for.